Hello, this is Professor Gardetto, and this is a mini video on some of the problems that you'll find on homework number two. Homework number two is about solving equations and inequalities. There's more equations than there are inequalities. So if you want a longer presentation on homework two, I suggest you watching our second live Zoom lecture, which is taking place this morning, the 15th of June at 9 a.m. It'll be recorded and on Canvas shortly thereafter. So let me preview the assignment here. All right, so there's 34 questions, and like I said, most of them are just solving equations. So we haven't seen the equal sign yet, but there's a balancing act here that has to take place when you solve an equation. The rule of thumb is what you do on one side of the equation, you also have to do on the other side of the equation. So you have to always keep the equality set. Think of it as like having, if you have like two bank accounts. If you have two bank accounts and they have the same amount, right? If you have a checking and a savings account and they have the same amount in it, and if you go withdraw $20 from your savings account, if you want to keep the accounts equal, you have to also go withdraw $20 from your checking account. If you add $20 to your checking account, then you have to add $20 to your savings account to keep them equal. So when you're solving an equation, you basically want to solve for the variable. So in this case, the variable is y. So we want to get rid of this minus 5. We want to get rid of this minus 5. All we want is y left over on the left-hand side. So to get rid of a minus 5, well, we just add 5. So we add 5 on this side, and we add 5 on this side. And if we add 5 on both sides, the negative 5 and the plus 5 cancel, so we're just left with y equals, and then we just have a simple integer operations to do. Negative 17 plus 5, which if you got through with homework number 1, you definitely want to do the homeworks in order. You don't want to do homework 2 before you do homework 1. But in homework 1, we talked about yesterday adding integers together. So negative 17 plus 5 is just negative 12. Okay, so now don't worry about here. It says the solution set. It's just all you have to do is just type in negative 12. Negative 12. And then check answer here is okay. All right, and we look for that. We look for that green check mark. Okay, so that's a very simple one. Let's go over one that looks a little bit more complicated. Decimals, if you have decimals here, I suggest just using a calculator. So I would just divide, well, this is negative 1.9x. So we get rid of the negative 1.9x by dividing by negative 1.9. So if we divide this side by negative 1.9, that negative 1.9 cancels with this negative 1.9, and over here on this side we divide by the same thing. Remember, we have to do the same thing on both sides. Do the same thing on both sides of the equation. And now for this one here, the negatives actually cancel. So if you're using your calculator, I was using my regular cell phone calculator here. If I just put this in 0.741 divided by 1.9, and I get 0.39. Doesn't say anything about rounding up here, so 0.39 would be okay to put in. I suggest you using a calculator for the ones that have decimals. Okay. What are these little 3 dots here? Let's see what this means. Let me hover over this. It says your answer is correct. However, it is customary not to start a number with a decimal point. I don't think you need to worry about that. It says the answer is correct, and I think they just want to have a. Oh, here's the alternate answer: 0.39. That's the same as 0.39. So don't really worry about that little three dot thing if you get that. That's kind of lame. Um, okay, so much more interesting equations are coming up here. I'm just kind of picking and choosing here. Oh, this one looks a little bit more interesting. Scary looking problem because of the fractions. So let's talk a little bit about fractions. Okay, fractions are not whole numbers. They are a little bit more confusing to most people. So what we want to do is we want to get rid of the fractions. Okay, so the way to get rid of the fractions is by looking at the denominator. So looking at the denominator, so I'm going to look at the denominator. I'm going to look at the bottom part of the fractions. I'm not even going to look at the top part of the fractions. I'm just going to look at the bottom part of the fractions. So we have 5 and we have 3. So now we think of a number that 5 and 3 both go into. Like if you counted by 5s and you counted by 3s, what number would we get to first? That's the same. And if you're thinking 15, you're correct. 15 is also what 5 times 3 is. So I'm going to multiply both sides by 15. I'm going to multiply this side by 15, and I'm going to multiply this side by 15. Okay, now the reason I do that is because watch what happens. This 5 cancels with this 15 and makes a 3. And this 3 cancels with the 15 and makes a 5. So basically, I now have no more fractions. The fractions denominators canceled. I put 5 into 15, and I put 3 into 15. Okay, now I have an equation that I can rewrite. 3 times negative 12 is negative 36. And 8 times 5, and don't cancel that n. That n right there shouldn't be canceled. There we go. Okay, so the 8 times the 5 is 40, and the n is in front of the 40, after the 40. So we have this. Okay, so now we need to solve for n, so we have to get rid of this 40. The n's on the right-hand side, so I'm going to divide both sides by 40. And I divide by 40, these 40s cancel. And here's my answer, but I don't believe this is simplified. Okay, they want the answer to be simplified fractions. So negative 36 over 40 is not simplified because, 36 and 40 are both even, so they can be divided by 2. So if you take half of 36, you get 18. And you take half of 40 and you get 20. And 18 over 20 is not simplified either. You take half of 18 and you get 9. And you take half of 20 and you get 10. Okay. You could also have divided 36 by 4 and gotten a 9, and divided 40 by 4 and got the 10. So when you simplify fractions, you just divide by the same number on the top and the bottom. So when you put your solution set in, you click the box and a little fraction icon comes up. Click the fraction icon, put negative 9 on top, click the bottom, put 10 on the bottom, and then check your answer. And you should get that green check mark. Okay. It's just going to take some practice. That's one that has fractions in it. Let me move over to another problem here. Okay, so this one here doesn't have fractions, but it does have parentheses. So what we want to do with the parentheses is we want to get rid of the parentheses first. So there's a property called the distributive property. And that means we're multiplying 4 times z, and we're also multiplying 4 times 3. So that'll get rid of the parentheses. So that's going to be 4z plus 12 equals 13z plus 21. I always cross my z's because they look like my 2's if I don't. Okay, so interesting thing here happens. You have z's on both sides. You have z's on both sides of the equation. So you have a choice. You can either get the z's on the left side or you can get the z's on the right side. But you have to get the z's on one side. You can't solve an equation if you have the variables on both sides. So I'm going to go ahead and subtract 4z on both sides just because I want to stay positive. I don't want to go into negatives if I don't have to. So if I subtracted 13z on both sides, I'd have a negative number over here. And it doesn't really matter. As long as you get the z's on one side, it doesn't matter if it's on the left side or the right side. So I'm subtracting 4z on both sides. I was careful to put the minus 4z underneath the z's, so they're like terms. 13z minus 4z is 9z. And now I have 9z plus 21. Okay, so now I got the z on the right-hand side. Now I have to get rid of the 21, and I have to get rid of the 9. Okay, I want to get rid of the 9 last. I want to get rid of the 21 first. Okay, so I'm going to subtract 21 on both sides. And 12 minus 21, I believe, is negative 9, which is nice because I have a 9 over here. And that just means when I divide by 9, I'm going to get a whole number answer. Negative 9 divided by 9 is negative 1. So I just can put negative 1 up here. Okay. And check my answer here. Okay. Let's see. Let me clear this. And let's move over to the inequalities. I think they start on number 23. Nope. 24. Nope. Okay, where are they at? I know I put some inequalities here. Okay, here's an inequality. Okay, so one thing we have to be careful with inequalities, that you solve them the same way as you solve equations, except for sometimes the inequality sign flips directions. Okay, when I say inequalities, I mean these signs that you've probably seen before. We have the strictly less than sign. We have the less than or equal to sign. We have the greater than sign, and we have the greater than or equal to sign. Okay, and most of the time, when you do the same thing on both sides of an equation, you can't flip an equal sign. But there is a time that you're gonna do something on both sides of the equation or for the inequality, and the sign is gonna flip directions. And let me tell you right away when that's going to happen and why. Let's say we had this inequality. 4 is greater than 2, and you guys would all agree with that. 4 is a greater number than 2. If we divide both sides by a negative, we'll just say negative 2. If I divide both sides by negative 2, 4 divided by negative 2 is negative 2. And 2 divided by negative 2 is negative 1. Okay, now this negative 2 is actually smaller than negative 1. And negative 2 is less than negative 1. So when I divided by a negative number here, Okay, and that's the key thing. When you divide by a negative number, the inequality sign flips directions. Okay, so instead of a greater than sign, it became a less than sign. Okay, and that's what's going to happen here. Okay, because we're going to solve this equation, or we're going to solve this inequality. I'm going to subtract 4 on both sides. Okay, so that doesn't flip anything. I have a negative 5z. I have a less than or equal to, and negative 11 minus 4 is negative 15. But when you divide both sides by negative 5, you have to remember to flip this inequality sign. So it's going to be now greater than or equal to, and negative 15 divided by negative 5 is 3. Okay, so this is our answer. There's 3 different parts to this answer, though. We're going to have to write it 3 different ways. So part 1 asks you for set builder notation. So set builder notation looks like this. It looks like, well, if you click this, blue box here, you'll see the set builder notation is, I believe it is right here. Okay, so click this box here, and we put the variable z, and see this little bar here? You leave this bar here. It just means such that. So all values z such that, and then in this box here, we put z. Let me see. It's going to be greater than or equal to. So I'm going to click this box here, and I'm going to put a z here, and then it's already got the greater than or equal to, and then I put the number 3. So it's basically the same thing as we have up here in red. Z is greater than or equal to 3, except for they have that z in the little bar. And then I think we can check our answer before we go to step 2 or part 2. And it gives us the green check mark. Interval notation. Interval notation is a different way of writing the same thing. Z is greater than or equal to 3. Let me show you what interval notation is about. So if you notice the rounded parentheses and then the brackets, if you have a greater than or equal to sign, you use the brackets. If you did not have the greater than or equal to sign, if we just had a greater than sign, we'd use the rounded parentheses. So let me write that down for a second. You use these when you have this sign or this sign. You use these when you have this sign or this sign. Okay, and it's best to be understood if I just showed you a graph here. So let me just show you a graph of a number line. Okay, so here's a number line here, and here is the answer, right? Z is greater than or equal to 3. So if I went over to 3, here's 0. Right? Here's 1, here's 2, here's 3. Well, 3 is part of my solution set because 3 is greater than or equal to 3. 3 is equal to 3. So since 3 is equal to 3, I'm just going to put a dot there. I'm going to put a dot. Okay, and then all the numbers that are greater than or equal to 3 are over here. So I'm just going to shade this area. I'm going to shade this area. And then all these numbers are greater than 3 too. So it actually goes all the way down the number line. Okay, and if it goes all the way down the number line, I'm doing a horrible job of shading, but all this area here is actually contained in our solution set. So it actually goes all the way down to infinity. So the way we build the solution set in interval notation